Ever get that feeling like you want to grasp the core of something really complex? Like how software actually gets built successfully, but without needing to become a coding whiz right away.
Yeah, absolutely. Like getting the big picture, the blueprint for a skyscraper.
Yeah.
You don't need to start with figuring out where every single rivet goes, right?
Exactly. And that's what we've got laid out in front of us today, some core concepts about software development. And our mission, if you will, is to pull out the essential stuff, the things that help avoid what one source calls organized chaos.
I like that. It really is about getting those fundamental pillars in place. Forget the trendy tools and all that for a second. We're talking about the timeless principles that keep a project from imploding.
Okay, let's start unpacking this. And the first thing that pops up, maybe it sounds obvious, but it's currently crucial: issue management.
Yeah, yes.
The source material is very clear. You need a system, a way to record every single change, every bug fix, every new feature, everything.
Right, from the very beginning.
Why is that so foundational?
Well, think about it this way. Imagine you're renovating a house, right? And you're not writing anything down, no list of what needs fixing, no plan for the new kitchen. You're just winging it.
Oh, that sounds like a recipe for a disaster.
It is. You'll have people disagreeing on what to do, forgetting tasks, things half done, issue management for software. It's basically that list, that plan. Without it, you're flying blind.
Makes sense. So you lose track of what needs to be done, what's being worked on, and if problems are actually fixed or not.
Precisely. It's a surprisingly common way to waste time and just create a lot of frustration for everyone involved.
Now, the source material digs into a couple of scenarios, which is helpful.
Sure.
You've got users, people actually using the software, reporting issues, things they've encountered.
Right. Real world problems.
And the source distinguishes between, let's say, a known problem, something with a temporary fix, a workaround, versus a brand new issue, something that nobody's seen before, a real head scratcher that needs investigation.
Yeah, that initial triage is so important for keeping users happy and also making sure developers, the people building the software, are focused on the right things.
So if it's a known issue, you can at least say, hey, we know about this. Here's a temporary fix while we get to the bottom of it.
Exactly. Provide some relief, buy some time. But a new issue, that's a whole different ballgame. That's where the real detective work begins.
Like a software whodunit.
Exactly. You got to recreate the steps, figure out if it's a glitch in the data itself, what the source calls rogue data, or if it's an actual error in the code, the instructions of the program.
And that brings up something that really struck me, this idea of replicating the issue, being able to actually reproduce the problem reliably. It's like a doctor needing to observe the symptoms, right?
Absolutely. If you can't make it happen consistently, it's so much harder to figure out what's causing it and then how to fix it.
The source also points out those two main suspects: bad data and errors in the code. It seems to me that knowing which one you're dealing with changes your whole approach.
Oh, hugely. If the software only acts up with certain data inputs, then the core logic might be fine. You might just need to clean up the data or validate it better.
Okay.
But if you get the same problem regardless of the data, then it's a good sign that the code itself has a flaw. Getting this diagnosis wrong can lead to a lot of wasted effort, chasing the wrong problem.
There's this really blunt question in the source that I love. How would you know that the issue is fixed without details of what the issue was and who reported it?
It's so simple, but so profound.
It seems so logical, but I can absolutely picture scenarios where those details get lost, buried in email chains or just mentioned in passing.
Oh, for sure. That information decay, it's a real problem in any collaborative environment. Without a centralized system, things just disappear.
You forget who reported it, which might give you clues about their setup or their workflow.
Yeah.
You might not have the exact steps that led to the problem, which makes it hard to replicate and fix.
Exactly. It becomes a game of telephone, and the message just gets garbled along the way.
Okay, so this brings us to what the source calls an issue management system. And it sounds like it's more than just a to-do list.
Yeah, it's really a structured way to handle the entire life cycle of a problem or a requested change.
Like a dedicated system.
Think of it as air traffic control for software changes.
I like that analogy.
It records the initial flight plan, the request, or the bug report. It assigns a pilot, the developer who's responsible for fixing it. And it tracks the progress through different stages, development, testing, ready for release, even cancellation.
It provides that single source of truth that everyone can refer to, so you don't have different people with different understandings of what's going on.
Exactly. It's all about bringing order to what could easily become chaos.
So issue management, that's our first critical piece for avoiding that organized chaos.
Absolutely.
It's about having that clear, documented journey for every change, big or small. Okay, so we know it needs to change. What's the next fundamental aspect of building software effectively?
Well, the source then dives into version management. It basically states that any serious development project, it needs to have a method of tracking changes to files, and that includes both code and documentation.
Version control, right? Like having a time machine for your project.
Exactly. The source points out that version 3 of a piece of software, it can be drastically different from version 1.
Oh, yeah.
You need a way to see those differences, to compare them, but also to go back to a previous state if things go wrong. Like, imagine writing a book and not saving different drafts along the way.
That sounds terrifying.
A complete nightmare. Now, picture a team of developers all working on different parts of the same software at the same time.
Okay, yeah.
Without version control, merging their changes would be incredibly difficult, super error prone. You would have conflicts, things breaking left and right.
Yeah, that makes sense.
Version management, it's like that central repository. It keeps track of every modification, who made it, when. It allows people to work in parallel without stepping on each other's toes.
So you can experiment and innovate without that constant fear of breaking everything permanently.
It's that safety net, that ability to undo mistakes that's so crucial.
The source also mentions things like performing merges and detailing differences between files. It sounds very technical, but I can see how that would be incredibly useful, especially with bigger teams.
Oh, absolutely. When developers are working on separate features, their code eventually needs to be combined. Version control systems, they have tools to do this intelligently, to merge those changes and highlight any potential conflicts.
So you can spot those problems early on.
Exactly. And being able to see exactly what changed between two versions, that's also invaluable for debugging, for understanding how the software has evolved over time. It's like having that detailed audit log of every modification.
And this versioning, it's not just about the code itself, right? The source specifically mentions versioning documentation.
Oh, that's so important. I mean, think about it. If the software changes, the user manuals, the help files, all of that, it needs to reflect those changes. Outdated documentation, it can be almost as bad as buggy software.
Totally. I've been there, trying to follow instructions for a feature that doesn't exist anymore. So frustrating.
Exactly. It just leads to confusion, a bad user experience. Version management, it keeps everything in sync.
So the documentation always matches the specific version of the software that someone's using.
Consistency and reliability.
Makes perfect sense. Okay, the source then introduces this idea of build management. It talks about the shift from individual developers building the software on their own computers to having a dedicated automated process for creating those builds.
Right, a more centralized approach.
Why is that seen as a more robust and reliable way to do things?
Well, think of it like this. Imagine you've got a bunch of chefs, each preparing a dish in their own kitchen with their own ingredients, their own methods.
Okay, yeah.
Now compare that to a standardized factory assembly line.
I see where you're going with this.
Building software involves multiple steps. Compiling code, linking libraries, packaging everything together. If each developer does this on their own machine, you introduce all sorts of variables. Different operating systems, different software versions installed, different configurations.
So many potential points of failure.
Exactly. An automated build system running on a dedicated machine, it standardizes the entire process.
Removes those inconsistencies.
It reduces errors and ensures consistency, so every build is created in the same way. And as a bonus, it frees up developers to focus on what they do best, writing code.
That makes a lot of sense. The source also emphasizes that this automated system should ideally pull the source code and related files directly from the version management system.
Oh, that's crucial. You want to be building from a known, controlled state of the code base.
So you don't accidentally include old files or incorrect versions that might be lurking on someone's computer.
Exactly. It's about building on that solid foundation that the version control system provides.
And then there's this connection between the build management system and the issue management system, right? It uses information from the issue tracker to know which issues have been marked as fixed, as resolved, and should therefore be included in the build.
Exactly. It's all connected. The issue management system, it acts as the roadmap for the build process. It tells the build system which changes are ready to go, which ones have been vetted and signed off on.
So you're not accidentally releasing half-finished features or code that's still buggy.
Precisely. Building with intention, based on that clear record of what's been done.
So build management, that's our third essential component. Automating and standardizing that process of turning code into a usable product. What comes after that?
Well, after the build is created, the source brings up baseline management. It really highlights the importance of knowing exactly what's in that build, specifically which source files have been modified.
Okay, it's like taking inventory. But why is that so critical?
Well, for one thing, it's crucial for testing. If you know exactly which files have changed, you can focus your testing efforts much more effectively.
Targeted testing.
Exactly. Instead of having to retest the entire application every single time, you can focus on the areas affected by the changes.
Which saves a huge amount of time and effort.
Huge. Think of it like a surgeon, knowing exactly which instruments were used in a previous operation.
Okay, interesting analogy.
That knowledge is crucial for planning the next one. And the source also points out that for complex software with lots of moving parts, knowing what's changed makes upgrades a lot smoother.
Right, because you're not replacing everything every time, just the parts that need to be updated.
Exactly. Baseline management tells you exactly which components have been modified, so you can upgrade those specifically without having to touch the rest. And of course, it also helps with targeted testing after the upgrade to make sure everything's still working as expected.
It's like updating a single app on your phone versus reinstalling the entire operating system.
Perfect analogy.
Okay, so baseline management, our fourth element, it's about having that precise record of what makes up a specific build at a specific moment.
A snapshot in time.
For testing, for upgrades, and just for having a clear understanding of the software structure. What's next?
Well, then the source moves into the realm of process and workflow management. It really emphasizes the need for control, over who can initiate a build, who has the authority to approve it, that sort of thing.
It sounds like it's about preventing chaos by having clear roles and responsibilities.
Exactly. You don't want just anyone kicking off a build whenever they feel like it, or untested software accidentally getting released. You need a defined process with checks and balances.
Checks and balances, like in government.
Exactly. Without established processes and workflows, you risk inconsistent builds, you risk quality issues, and a lack of accountability.
Yeah, it quickly becomes the Wild West.
Right. Process and workflow management, it defines who can trigger a build, what approvals are needed at each stage, what criteria have to be met before moving to the next step.
It's like having a roadmap, but also traffic signals along the way, making sure everything flows in the right direction.
Perfect.
The source mentions these product versions and the need to clearly define what's included in each one, these deliverables. What are those exactly?
Think of them as the functional building blocks of the software.
Okay.
Like each deliverable might be made up of one or more source code files managed in the version control system. And each deliverable can have its own version number, so you can track the evolution of those individual components.
Like Lego bricks that make up the larger structure.
Exactly. And these deliverables are also tied back to the issue management system. They get marked as development complete and associated with a specific product release.
So everything's linked together, traceable.
Precisely. Once the development work is done, the changes are integrated, the issue is marked as complete, and that deliverable is earmarked for a specific release.
It's like a beautifully orchestrated symphony of information flow.
I like that.
The source also mentioned something called process reporting, which gives a high-level view of what's included in a new release. That sounds useful, especially for managers and stakeholders who don't need all the technical details.
Oh, absolutely. Process reporting provides transparency. It lets people see at a glance which features are included, what bug fixes have been made, all that, without getting bogged down in the nitty-gritty.
It's like the executive summary of a complex project.
Exactly.
So process and workflow management, that's our fifth element. It's all about having control and visibility over the entire development process.
From start to finish.
What's the final piece of the puzzle?
The last element the source covers is release management. This encompasses both the testing of the product, making sure it actually works, and the mechanisms for actually getting it into the hands of users.
The moment of truth.
Exactly. Testing involves checking that the software behaves as expected, comparing it against those initial requirements, making sure the requested changes actually work.
Yeah. And I imagine it also involves making sure that fixing one thing didn't break something else.
Absolutely. Regression testing, the source calls it. You want to make sure that fixing that leaky faucet didn't somehow cause the toilet to start running.
A very apt analogy.
As software evolves, changes in one part can have unintended consequences in other areas. Regression testing helps catch those issues before they reach the users.
It's like a safety net.
Exactly. And then there's the actual release mechanism itself. How do you get the software to the people who will be using it.
Yeah, different strategies for different situations.
The source talks about everything from those seamless background updates that happen automatically to manual downloads and installations.
And it also mentions the importance of tracking how many people actually adopt a new release.
Oh, that's crucial feedback. It can tell you how successful a release is, if there are any issues preventing people from upgrading, things like that.
So release management, our final element, is all about controlling both the quality of the software through testing and the actual deployment process.
Getting it out into the world.
And as the source emphasizes, it's really important to understand that these 6 elements, all these things we've talked about, they don't operate in isolation.
They're all interconnected, they're interdependent. You can't just pick and choose a couple and expect everything to work smoothly.
It's a system, a holistic approach to building and releasing software reliably.
Exactly. By incorporating all 6 elements, organizations dramatically increase their chances of success. They get more predictable outcomes, more efficient processes, and they avoid that organized chaos.
So, for you, the listener, as you consider all these pieces of the puzzle, which one resonates most with you? Which one seems like it could have the biggest impact in your own context?
It's a good question to ponder.
What questions are bubbling up for you as you think about this whole system? That's something to keep in mind. Thanks for taking this deep dive with us.
Absolutely.
Until next time.
See you then.